Alright, so the other day we spoke about linear proportional relationships in terms of tables. Now we're going to talk about linear proportional relationships in terms of graphs. So you can represent a proportional relationship with a graph. The graph will be a line that passes through the origin 0, 0. The graph shows the relationship between distance measured, which is over here in miles, versus to distance measured in leagues. Leagues is a term that people who use ships use, okay? So this is going to be my independent variable for this situation. This is going to be my dependent variable. So this is my x, this is my y. Now, we're going to solve this two ways. We're going to solve this with the constant of proportionality, k equals y over x. And then we're also going to solve it with slope, which is going to be our rise over our run, which I mentioned briefly in the last video, which is going to be delta y, which means change in y, over delta x. Okay, we're going to use both of them to let you know that you could use these interchangeably when you have a proportional relationship. Okay, so k is equal to, let's use this point over here, 3, 9. So my y value is 9, and my x value is 3. So once I simplify that, divide by 3, we get 3 over 1. So k in this case is just going to be 3. Alright, so since it's a linear relationship and it is proportional, it should work for any of these points. So I'm just going to try one more so you can see that it does. I'll use the point 6, 2. So my y value is 6, my x value is 2. Divide by 2, we get 3 over 1. So as you can see, k is still 3. Now, let's talk about the slope. What if you wanted to use the slope? I could have had this point right here because it's at the origin, so I can use that. It's going through the origin, so the origin is going to be a point 0, 0. I'm going to grab another point, and then I'm just going to create a triangle. Okay? This over here is going to be my rise. So I go from 0 to 3. So I rise 3. So my rise is going to be 3. I go then, look at my x values left to right. I go, well, positive 3. It's because I'm going up. So left to right, I go from 0 to 1. So this is 1, positive 1. I go to the right. Right is a positive action. So 3 over 1 is, of course, just going to be equal to 3. So as you can see, it doesn't matter if I use constant of proportionality or slope. My rate of change is still going to be the same. So you'll have to know how to use both of them interchangeably, but slope, it will be a lot more useful if you have a graph. Okay, so let's go ahead and create our equation now. So we have y equals kx. Our k here is going to be equal to 3. So our equation is going to be y is equal to 3x. Alright, using either the constant proportionality or the slope. Let's try another example. Alright, so the graph shows the relationship between the number of days a car is rented and the total cost for the rental. Write an equation for this relationship. So the days is my x value and the total cost is my y value. Alright, so the total cost depends on the amount of days. So let's go ahead and use both again. K equals y over x, and then slope is equal to the rise over the run. Now, for my k value, let's just say I use, let's use this point here. So that's going to be 1, 2, 3, 4, 5, 6. You always have to pay attention to the scale though, because sometimes it's not always going to go by ones. So it's going to be 6 as my x value. My y value, as you can see, it's not 1, 2. It's going by hundreds. So it's going to be 100, 200. So this is going to be 200. So my y value is 200. And my x value is 6. Now I can divide top and bottom by 2. I don't think there's another greatest common factor besides 2 here. So divide by 2 is 100. Divide by 2 is 3. So k is equal to 100 over 3. You keep it as a fraction if you would like, or you could simplify this by dividing to 33.33 repeated. So my k value is going to be equal to 33.33 repeated. Now, let's go ahead and do our slope. Since I picked this point, let me pick another point in order to do slope. Let's go from here to here. right? So my rise is how much I go up. I go from 300 to 400 to 500 to 600. So the difference is from 600 to 300, that is 300. Okay, so my rise is 300, and my run, I go from 9 all the way to 16, 17, 18 to 18. So 18 minus 9 is going to give me 9. Okay, so 3, 4, 5, 6, that's 300, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Okay, so now I'm going to just divide by 3 and divide by 3. So this is 100 over 3. Once again, as you can see, I get the same thing. So 33.33. Now let's write our equation. Y equals kx. Y is going to be equal to, I could either keep it as a fraction, 100 over 3, and then x, or I could say y is equal to 33.33 repeated x. That's basically it. Okay, now at this point you could feel free to stop the video. You have all the information that you need, but if you want to see another example, go ahead and continue to watch the video. Okay, so here's another example. The graph shows the relationship between the weight of an object on the moon and its weight on Earth. Write an equation for this relationship. So this is my x value, this is my y value. So y is going to be equal to k over x. So let's say I choose 30, so this is 30 for x, and then this is 5 for y. So, I keep messing this up, k equals y over x, there we go. Alright, so our y value here is 5, our x value here is 30. So divide top by 5, divide bottom by 5, I get 1/6. Now I can turn this into a decimal, but I'm not going to. I'll just keep it as a fraction when I put it in my equation. So k is equal to 1/6. Now let's go ahead and take a look at the slope, which is equal to the rise over the run. I could pick any point, but honestly the easiest point to pick when it's a proportional relationship is starting with 0 and going to that next point. So I'm going to rise 1 here, and I'm going to run 6. Alright, so that's positive 1 because I went up, and positive 6 because I went to the right. So that's just, once again, 1/6. So y is going to be equal to, my equation is 1/6, and then we switch back to purple, x. So this would be my equation. Y is equal to 1/6x. Now, let's just say that I want to know how much I'll weigh on the moon if on Earth I weigh 60 pounds. Okay, Earth I weigh 60 pounds. Now, how would I go about figuring that out? Well, I know that my equation is y equals 1/6 x. I know that x represents my weight on the Earth, and y represents my weight on the moon. Okay, so I'll just plug in the information that I do know. I was saying that I weigh 36 pounds on Earth. So 1/6 times 36 is going to give me how much I weigh on the moon. So 36 over 6 is going to be equal to y. Y is equal to 6 pounds. Okay, so I would get a point 36.6. That means if I weigh 36 pounds on Earth, I would weigh 6 pounds on the moon. Just something to think about. Here's our last example. Once again, I want to figure out the constant of proportionality, or the slope. The graph shows the relationship between the number of cups of flour and the number of cookies made. Write an equation for the proportional relationship. Once again, y is equal to, k is equal to y over x. So my y here, I'm just going to pick this point. My x value is 12, and my y value is 192. Okay, so we got 192 over 12. Alright, so 192, I believe that 12 could go into 192 if I just divide it by 12. So 192 divided by 12 is going to be equal to 16, and then 12 divided by 12 is equal to 1. Now, of course, if you didn't know that, you could have kept halving it until you couldn't anymore. So my k is going to be equal to 16 here. Now, slope, easiest thing is to start with the smallest points But in this case, I'm just going to start, since I could see this 96, I'm just going to go here and here, so I don't have to calculate anything there. So from 0 to 96 is 96. So my rise over my run is going to be equal to 96 over, this goes from 0 to 6 is my x value. So divided by 6, 16 over 1, my slope is going to be equal to 16. So my equation is going to be y equals 16x. Y equals 16x. And that's it.